Hi friends, in this video we are going to discuss about the previous gate question. Right, next question. Let's see. Two parallel connected 3-phase 50 Hz 11 kV star connected synchronous machines. A and B. A and B, two parallelly connected synchronous machines. Operating as a synchronous condenser. These are operating as a synchronous condenser. They together supplies 50 MVAR. They together supplies 50 MVAR, nothing but 25 MVAR. 25 MVAR. Right? To a 11 kV grid. The current supplied by the both the machines are equal. Current supplied by the both the machines are equal. Nothing but this 25 MVAR is equals to root 3 VL, root 3 VL nothing but 25 MVAR is equals to root 3 11 kV. 11 kV by root 3 VL IL sin phi VL IL sin phi VL IL sin phi. They are synchronous condensers. Synchronous condensers nothing but purely capacitive or purely inductive, purely capacitive, like that. So its value 90 degrees. If you calculate this IL is equals to 1312.2 amperes, this value same both for machine A and machine B. For both, this value is same 1.13.2 amperes. Synchronous reactances they given XA 1 ohms per phase, XB 3 ohms per phase respectively. Assuming the magnetic circuit to be linear, the ratio of excitation currents of machine A to the machine B, the field current of machine A to the field current of machine B is how much? This is the question. Tell me what is the answer. What is the answer? IFA by IFB. Actually, there is no possibility to find IF, but we know the field current which is directly proportional to induced EMF. Field current directly proportional to induced EMF. So IFA to the IFB nothing but EA to the EB. This is we have to find out. Then tell me what is EA to the EB? EA is nothing but VT minus IA into XA divided by VT minus IB into XB. This is the value. So tell me what is the value? See here. Tell me EA divided by EB is equals to, if you calculated EA is 11 kV by root 3 plus minus because this is a motor, synchronous motor, minus IA 1312.2 into XA. What is XA? XA is the 1. This is the 1 actually at an angle 90 degrees. And this is also the current at an angle 90 degrees. And what is EB? EB is equals to 11 kV minus 131.2 at an angle 90 degrees and 1 at an angle, what is XB? XB is the 3 at an angle 90 degrees. 3 at an angle 90 degrees. If you solve these two, you can get EA is equals to 766.7663.05 and EB is equals to 10287.45. 10287.45. If you calculate this EA and EB is equals to 0.745. So your answer is 0.745. Your answer is 0.745 is the correct answer. But we have to find out many. Here, first we have to find out the current, then after EMFs, then after the ratio of EMFs. But this is, we have to know the EMF is directly proportional to field current. That's why I am going to find out the field currents irrespective. Actually, we have to find out the field current, but I calculated the EMF. The ratio of EMF, nothing but the ratio of field currents. That is the matter here. Okay, next question. Very simple question. In a synchronous motor, if a synchronous motor running at leading power factor, synchronous motor running at leading power factor, its excitation induced EMF is synchronous motor, right? I have to take synchronous motor. The main field flux lagging 90 degrees to the EMF. 90 degrees to the EMF. Next, power factor, leading power factor. Leading power factor, nothing but 90 degrees leading. 90 degrees leading, nothing but this is my armature current and armature flux. Armature current and armature flux. Let's see here what happened here. This is the armature flux direction and this is the main field flux direction. So demagnetization, nothing but over-excitation condition. Over-excitation, nothing but E cos delta is greater than V. E cos delta is greater than V. So now tell me, which of the following is the correct answer? Equal to the V, the excitation EMF equals to the V, the excitation EMF less than V, the dependent upon VT, of course, but higher than VT. This is the terminal voltage VT. E cos delta is greater than terminal voltage. So the EMF is, excitation EMF is higher than the terminal voltage. Right, next question, see here. A 3-phase 50 Hz generator supplies the power of 3 megawatts. Power of 3 megawatts. Generally, P is equals to, in generally, VI cos pi, they given 3 megawatts. At 17.3 kV to balanced 3-phase inductive load. This is 17.32 kV to the balanced inductive load. Through an overhead line. Here the power, the voltage 17.32 kV. The per phase line resistance and reactance they given. This line resistance and reactance they given. How much? 0.25 ohms, 3.925 ohms. If the voltage at the generator terminal, 17.87 kV, this is the load. Here, load, where P 3 megawatts, Then we have to find out this power factor. We have to find out this power factor. Actually, this is the source generator here. Now, for example, here the current is I. For example, here the current is I. For example, this is sending end voltage and this is the receiving end voltage, Vs, Vr. The difference between sending end and receiving end is the impedance drop. Yes or no? I am sending some voltage. Here some voltage received. What about remaining? Here the voltage drop. Voltage drop nothing but I into R plus X. Nothing but R cos pi plus X sin phi. R cos pi plus X sin phi. Actually, we know Vs, we know Vr, but I don't know I. But from this we can find out I also. Yes or no? We can find out I also. This is the receiving end voltage, receiving end current, receiving end current. Actually, this is the receiving end current, of course. Yes? So tell me what is the Vs minus Vr is equals to? IR is equals to the receiving end power by Vr into cos pi multiplied R cos pi plus X sin phi. Nothing but Vs minus Vr is equals to PR by Vr into R plus PR into X by Vr tan phi. From this we have to find out tan phi by substituting all the values. We have to find out tan phi. Then after phi is equals to, then after we have to find out phi. Then after we have to find out phi. Phi is equals to tan inverse of something value. We can find out the phi. Then after power factor is equals to cos of this phi. If you substitute all the values, if you find phi, then after, if you find phi, actually the phi value you can get 36.86 degrees. If you get a phi after solving this, then you can get phi is equals to 36.86 degrees. If you substitute this 36.86 here, you can get 0.8 lagging. 0.8 lagging. So what is the power factor? 0.8. What is the power factor? 0.8 is our answer. The load is 0.8 power factor. The load is 0.8 power factor. See what I done here? The difference in sending end and receiving end is the drop. This drop I calculated. From that I substituted all the values. Then I calculated tan phi. Then after phi 36.86 degrees. Then if you find this value 0.8 lagging for this question. Next question. See here. At 25 kV, P 25 kVA, 400 volts, delta connected. So phase voltage also 400 volts. 3-phase cylindrical rotor synchronous generator. Field current 5 amperes. To maintain the rated armature current under short circuit condition. This is the field current. For the same field current, the given EOC 360 volts open circuited voltage. Armature resistance neglected. The magnetic saturation considered. Its voltage regulation its voltage regulation. When the generator delivers the rated load at 0.8 power factor leading with rated terminal voltage. This is the question. So voltage regulation is equals to E minus V by V. We have to find out E. E is equals to square root of V cos pi plus IARA whole square plus V sin phi minus IAXS whole square. Why it is minus? Because of leading load. It is the minus. So E is equals to square root of V. What is the V phase? 400. What is the cos pi? 0.8 whole square because RA 0. V 400 sin phi 0.6 minus IA into XS. The given XS, is there any XS? No XS, no IA. So we have to find out both IA and XS. How we can find? P is equals to root 3 VL IL. So IL is equals to 25K by root 3 400. If you calculate this value, this IL nothing but IA is the value. If you calculate this value, its value 36.085 amperes you can get. Around 36 amperes you can get. Now tell me, IA line this is. I want phase current 36.085 by root 3. Now this I phase is equals to 20.83 amperes. 20.83 amperes. I got IA 20.83 amperes. Now I want excess. Then after whole square. How much excess? This is IA at phase current. This is IA phase current. I have EOC. I have IA phase. Nothing but under short circuit condition. This is our ISC. So tell me, what is X? So X is equals to EOC by ISC. X is equals to, or XS is equals to 360 divided by 20.83. 360 divided by 20.83. If you calculate this value, its value 17.28 ohms per phase. If you calculate this value, you can get the excess value 17.28 ohms per phase. 17.28 ohms per phase. Excess value, X is equal to EOC by ISC. IA value from this one. Actually, this is line. We have to convert into phase. Then the EMF E is equals to EMF. How much EMF is there? Is the value 341.76 volts. This is the no load voltage. Because of leading load, the no load voltage is less than full load voltage. No load voltage is less than full load voltage. Now I want voltage regulation. Tell me, sir, voltage regulation is equals to E minus V by V. What is E? E 341.76 minus 400 by 400. If you calculate this value, you can get minus 14.56% is our voltage regulation. The answer is minus because of leading. The regulation 14.6 percentage, 14.56 percentage. What I calculated here, first EMF, I have to find EMF because voltage regulation. But I don't know IA, I don't know XS. IA calculated from the power, XS calculated from EOC and ISC. I substituted, I got EMF, then voltage regulation, voltage regulation, voltage regulation. This is very simple question. Yeah, this. Right, next question. In a silent pole synchronous motor, the developed reluctance torque attains the maximum value when the load angle in electrical degrees is. Actually, the torque T is nothing but P by omega. What is the P in silent pole machine? In silent pole machine, P is equals to EV by XD into sine delta plus V square into sine 2 delta by 2 multiplied by 1 by XQ minus 1 by XD. 1 by XQ minus 1 by XD. So this is actually the power developed by the machine. EV by XT into sine delta is the electromagnetic power which depends on excitation. If excitation 0, some power will develop in the machine is called reluctance power. Reluctance power. This is the reluctance power. So torque T is equals to P by omega, nothing but 1 by omega into the same EV by XD into sine delta plus V square sine 2 delta by 2 into 1 by XQ minus 1 by XD, 1 by XQ minus 1 by XD. This is the reluctance torque. Reluctance torque. Now tell me, when this torque is the maximum, when the load angle, the sine 90, when we can get sine 90, then this value is the maximum value. When we can get sine 90, if you get sine 90, the delta should be 45 degrees. When delta is the 45 degrees, then we can get, this is the maximum power by omega, nothing but we can get the maximum torque. So what is the answer? 45 degrees. When delta is the 45 degrees, then we can get the maximum reluctance torque. Right, next question. See here. A three-phase synchronous motor draws 200 amperes from the line at unity power factor. 200 amperes at unity power factor. At rated load. Considering the same line voltage and load. Nothing but generally P is equals to VI cos pi. P is equal to VI cos pi. They are telling that same line voltage and same load. If load is same, the power is same. Then the line current at power factor 0.5 leading is 0.5 power factor leading is, we have to find out the line current. Generally, we have to find out line current, the given power factor, when the same voltage and same load, the I cos pi should be constant. Then only the power is constant. Here V constant already they given. If I cos pi is constant, then the load is constant or power is constant. I cos pi constant, nothing but I1 cos pi 1 is equals to I2 cos pi 2. I1 cos pi 1 is equals to I2 cos pi 2. I1 they given 200, power factor they given 1. Unity. I2 we have to find out, power factor they given 0.5. So I2 is equals to 200 by 0.5. So I2 is equals to 400 amperes. This value 400 amperes, 400 amperes is our answer. So how we can find out that? When the terminal voltage and the load constant, the Ia cos pi should be constant. Ia1 into cos pi 1 is equals to Ia2 into cos pi 2. Ia they given, cos pi they given, I2 we have to find out, cos pi 2 they given, then cos pi 2. Substituting all the values, I2 is equals to 400 amperes. Next question, see here. A 220 volts line voltage, 3-phase, star connected synchronous motor. So they given line voltage, right? Line voltage 220 volts. What is the phase voltage? 220 by root 3 is the phase voltage. The motor draws the rated current of 10 amperes. Rated current of 10 amperes. Power factor 0.8 leading. Power factor 0.8 leading. 0.8 leading. And they given synchronous impedance directly 0.25 plus Z2.5 ohms per phase. Then the RMS value of line to line internal voltage in volts is the given, round off to 2 decimal places. Round off to 2 decimal places. First of all, this is the motor. That's why what is the EMF? E is equals to V plus. E is equals to V plus. Sorry, E is equals to V minus I into ZS, IA into ZS. Yes or no? For motor, right? For motor, E is equal to V minus IA into ZS. So find out, this is the phase value actually. Vt, they given 220 by root 3 at an angle 0 degrees minus Ia. What is Ia? 10 amperes at 0.8 leading. 0.8 leading, nothing but phi is equals to cos inverse of 0.8. How much it is? 36.86 degrees. And ZS 0.25 plus Z2.5. We have to solve this. If you solve this, the EMF for phase value, if you solve this, the EMF for phase value 141.658 at an angle minus 8.728 degrees. E phase value, this is. But generally they asked in terms of line to line volts. Line to line. For star connection, line voltage is equals to root 3 times of phase voltage. We know this. Now tell me, what is the line voltage? Line voltage is equals to root 3 times of phase voltage. Nothing but root 3 into 141.658. Root 3 into 141.658. Now if you calculate this value, you can get line to line voltage. Line to line voltage, you can get 245.36 volts. If you calculate this value, the answer is 245.36 volts. 245.36 volts, the phase voltage and the line voltage. But they asked me line voltage 245.36 volts up to 2 decimal places. So this is the answer for this question. Very easy. Just we have to find out EMF Vt minus Ia into Zs. They given Zs already. Ia they given with power factor angle. Yeah, this is our question.